Hi everyone, this is our video for our project FridgeMate, Smart Fridge Management System. Our motivation is to develop a system to help people to manage their groceries and keep track of their fresh food. Here's our system diagram. It's primarily composed of a local sensing part, a cloud server part, and a user-facing web app section. Next, we'll talk about the hardware part.
Hello, and let me introduce the hardware layout of this fridge. So firstly, this is a infrared sensor, and we set it on this side of the fridge door, which can detect if someone has came by and opened the door. And secondly, this is the temperature and the humidity sensor, which can detect the temperature and the moisture matrix of this fridge. And thirdly, this is a camera, and we use it to detect the real-time situation of this fridge. And we also have deployed a same model on this camera, and which can classify the food we put in the fridge. And yeah, this is the microcontroller and the breadboard we use to connect off the sensors. And this is the battery we use it to charge the microcontroller. And we also have set a light intensity sensor at this place, which can detect the light intensity and to provide more environment metrics of this fridge. So this is the basic hardware layout of this fridge.
I will be talking about the computer vision model part of our system. In our case, we decided to implement and deploy the FOMO model, or Faster Object, More Object model, a pre-trained computer vision model based on MobileNet v2. It is a small model taking up at peak around 200 to 300 kilobytes of RAM and as such well suited for the ESP32 CAN board we're using. It can detect multiple objects and classify them based on labels. And once these data are gathered, our ESP32 board will send the data to the server backend through an HTTP post request.
Okay, with the connection of the hardware in the fridge, we realize our real-time monitoring system, and we deploy our system on the public server with the public IP address. And our function could divide it into four parts. First part is the live camera feed part. It will show the real-time condition in the fridge. And the second part is the fridge matrix part. It will show the environmental information and the food item quantity states, which is distinguished by the same model deployed on the ESP32 board. The third part is the fridge notification part. It will give user a reasonable notification or warning that based on the environment and all the food condition. And the fourth part is the recipe suggestion part. We integrate the large language model into our system, and the model will give the recipes based on the food condition and the quantities. And the next step is the function experiment. We first put an orange into our fridge, and the camera detected the orange with the quantity 1 and the state is fresh. Also, because the door is opening, so there is a notification about the door is opening, because the infrared sensor detected the abnormal value, and here is the warning about the door opening warning. And based on the current food condition, we could use the large language model to give us the creative recipes. And the model we used is the GPT-4o here. And we use the structure output to achieve a stable output about the recipes, which contains the ingredients, method, calories, and time. You could see here the ingredients, method, calories, and time. And we also assign the label about their calories and time, such as low calories and quick meal. And this is our overall system introduction. Thank you for your listening.